Okay, welcome back guys, and in this video we are going to see electric motor concept from your class 10. So class 10, if you see the chapter magnetic effects of electric current, you can find this topic. In this lecture totally we'll discuss about electric motor. This is the diagram where we can get in your textbook, and in examinations if they ask you to draw diagram and explain, you should draw this diagram. I'll explain you what is this diagram. Before that, we'll see few pictures of motor where we'll be using in our daily life. I'll explain you regarding what is this N, what is this S, what is this A, B, C, D, this and all. Fine. You are very familiar with this picture where you can find this. This is motor. You can find this in toy car, making of small robots, right? Some machines, in fan. You can find this motor. Motor consists of two parts, guys. First one is stator, second one is rotor. In the name itself we have stator means which is static, rotor means which will be in motion. If you see this DC motor, this entire part is stator, and you can see one small rod. This rod, actually you should not call this one as rod, this is shaft. We have to call shaft, and this shaft is rotor. This is the only part where you can observe. Here you have two terminals. If you take a battery or small cell, consider this is positive terminal and this one is negative terminal. Take two wires, connect one wire to this terminal, another wire to this terminal. What you can observe, this shaft will rotate, it will be in motion, and this entire part will be static. Only this shaft will be in motion, rotor we can call. So from this what we can get, motor has two parts, stator nothing but static part, rotor means part which is in motion. Then this is just a diagram where the internal parts of motor can be observed. Here no need to draw this diagram. This is just for your information. Fine, for your information, this is the picture. No need to draw in your books. So this is outer frame, outer part, and this and all no need of this end brackets, no need to remember this. And you see the word given shaft. This rod is shaft, and these are bearings. You might have heard about ball bearing. Why ball bearings are used? To reduce friction, isn't it? To reduce friction, which you have learnt in your 8th class physics. And you see guys, this entire part is rotating part which will be inside. Here the coil part where copper, where you can find copper turnings, that part is known as armature. ARMATURE, armature. So armature is rotating part which contains copper turning. Then this is back part where we can observe, here they have given it is stator which will be static, entire this part is static. And here you can observe two things, commutator segment, we'll discuss that what is commutator, and brush. Brush you can call, or you can call as carbon brush. Carbon brush. We'll discuss what is commutator, what is carbon brush, what is armature. We'll see definitions too. Then, so I told you here, armature is a segment which contains copper turning. If you observe this diagram, this is shaft, isn't it? This is shaft. This entire part is rotor part. This entire part is rotor. Total part will rotate inside motor, and you can find these copper turnings. Copper turnings. And if number of turns increases, RPM increases. What is RPM? If you see bike, they will say 1000 RPM, 1500 RPM. RPM stands for rotations per minute. Rotations per minute. So if you have single turning, slowly it will rotate. If you have 10 turnings, RPM will increase. If you have n number of turnings, more RPM will be there, because number of turns increases, magnetic field, force, everything will increase. Then you can see this motor, assembling of motor. So this entire part is stator, and this part is rotor. Of course, this is not rotor. This is not rotor. This one is rotor. Okay, this is not rotor. This is armature segment. In this there will be copper wires, copper turning, and this rod is shaft. So this one you can find, right? This here inside you can find copper turnings. Inside this also you can find copper turning, and this one is shaft, and you have this is armature segment, and this one is stator. Inside this back there will be commutator segment, etc. So this end also, this part where inside there will be commutator, brushes, etc. We'll discuss all those concepts. So these are the pictures. You should have some idea. We'll discuss this picture. Motor. In motor there will be two parts, stator and motor. Rotor. Stator means which will be static. Rotor means which will be in motion when electricity is given. So stator rotor combinedly called motor, right? Motor means combination of stator plus rotor. So these things you should have some idea. Moving forward, we'll see a definition of motor and parts present in motor. So first we'll see what is electric motor. If they ask you to what is electric motor, if the question is for 1 mark, what answer you have to write? Electric motor is a device which converts electric energy to mechanical energy. So if you observe your house, you have fan, grinder, mixer, and you can find washing machine. So if you observe everything, where you can find motor, where the input is electric energy and output is mechanical energy. Mechanical energy, it will do different works. Fan, if you see, that will rotate and it will give us cool air. Grinder, it will grind. Mixer, it will make some powder or something. Washing machine, it will wash our clothes. Everything we can find it, isn't it? So electric motor is a device which converts electrical energy to mechanical energy. Now guys, every device works with one principle. Now while coming to electric motor, what is the principle of electric motor? The principle of electric motor is based on the fact that current carrying conductor produces magnetic field around it. That's it, right? If you take conductor, if you pass electricity through that, it will become current carrying conductor, isn't it? Current carrying conductor. This current carrying conductor, definitely it will produce magnetic field around it. Hence, it behaves like magnet. A current carrying conductor placed perpendicular to the magnetic field experience a force. So if the current carrying conductor is placed in magnetic field, you see this current carrying conductor itself producing magnetic field. If you place this near a magnet, when two magnets are present, two magnetic fields will be present. So if two magnetic fields are present, it will experience a force of attraction or force of repulsion, whatever it may be. It will experience a force. That is the concept. Or simply to say, electric motor works with the principle of with Fleming's left hand rule. Whatever it may be the answer, correct. Straight away you can write electric motor works with Fleming's left hand rule, that is correct, or you can write this paragraph 2. Next we have to see parts, construction of motor. First one, armature coil. It consists of single loop of an insulated copper wire in the form of rectangle. So if you see this diagram, you have one rectangle from here to here, right? One rectangular loop you can find. This rectangular loop is known as armature. So armature count increases, RPM increases. That's what I told you. Armature nothing but copper turning. That is one turn, only one rectangular turn you can observe. Next, strong field magnet. Armature coil is placed between two pole pieces of strong magnet which provide magnetic field. You can see this armature coil is placed between two magnets. Here we have north pole, this one is south pole. If you feel this diagram is incomplete, you can complete this by using lines like this. So it is horseshoe magnet itself. Okay, fine. Horseshoe magnet. Or here you can find diagram, horseshoe magnet. In middle, what they have arranged? Armature. So this yellow one is armature and this one is magnet which produce magnetic field. Next, split ring type commutator. Guys, here while coming to commutator, you have two types. First one is split ring. Second one is split. Second one is slip ring. So split ring is used for DC generator. Slip ring is used for AC generator. Sorry, DC motor and AC motor. DC motor, AC motor. What is meant by DC? DC stands for direct current. AC stands for alternating current. For our house or school, we'll get AC, alternating current. If you see railway engines, if you stand near the railway gate, you can find boards like 10,000 volt DC. So that is direct current. This is alternating current. So regarding this DC and AC, you are going to learn in your 12th class, not in 10th. Here. So we are talking about now at present DC motor. In next lecture, I'll tell you about AC motor. DC motor means what ring we have to use? Split ring. In the name itself, we have split. Simply to say, take one ring and cut the ring in two parts. If you cut it, what will happen? This is first part. This is second part, isn't it? Just we have splitted it. Split the ring, it will become split ring. Simple. Cut the ring into two parts. Then, while coming to split rings, it consists of two halves of metallic rings. Yeah, two halves. If you take one metallic ring, cut that metallic ring into two parts, it will become two halves. The two ends of armature coil is connected to these two rings. So commutator reverses the direction of the current. You see, if you observe this commutator, right? This commutator, one end is connected to one half ring. Second commutator is connected to second half ring. Here you can find this, right? This is one complete ring, which is like a cylinder, complete ring like this. Now, if you cut that cylinder, what will happen? It will become two parts, isn't it? This is first part, that is second part. So like that, you can cut that. So take a ring, cut it, it will become one piece and second piece. You can observe one end is connected to one piece here. Second end of armature is connected to second ring, split ring. So this one you can call it as S1 first split ring, S2 second split ring. So till now we have discussed about armature, which is nothing but rectangular coil, copper coil. Next, magnets. So this current carrying conductor should be placed in between magnetic field. Number 3, split rings, because this is DC motor. Next, brushes. So this is not the regular brush which we will use in the morning to brush our teeth. These are carbon brushes. Press against the commutator. These brushes act as contact between commutator and terminal battery. If you see here, this diagram, this one, or I'll show you this. In this diagram, we can find this split ring and this one X, this X and this Y are brushes, which will be holding it and which will pass electricity through it, and brushes will be static. You see here, which one is static, which one is rotating part, we'll discuss. This magnet is static, this magnet is static, this axle, support, axle means support, this support is static, these brushes are static, and this battery, this is also static. Now, what is rotating part? This armature is rotor. These split rings, that is also rotor. Fine. So only two rotors we can find. First one is this rectangular coil is one rotor. This split ring is one rotor, and remaining everything will be static. When electricity is given, that coil will rotate. Next, as usual, okay, battery, which is connected across carbon brushes, it supplies electric current. So these are the parts. You must remember 5 parts. Armature coil means it is single loop of insulated copper wire. Second, strong magnets. Definitely magnets are needed to produce magnetic field. Split rings, ring which is cut into two pieces, which is attached to, so connected to armature coil. To the two ends of the armature coil, these two rings are connected. Brushes will press the commutator segment. Commutator segment is this one only, this entire part. This part is commutator segment, where here brushes are connected. Here one brush will be present, here another brush will be present. This blue color marking you can find, this is brush, where it is used to reduce the friction, at the same time which is used to pass electricity such that it will rotate. Now let us see working of motor. It is quite easy to understand. Let us see the motor. In the side AB of rectangular coil ABCD, the direction of, okay, no need of this, just I'll explain. Easily you can understand this. So guys, consider this is schematic diagram of motor. So how to draw this diagram? I'll explain you. So first, let me draw here. First, you need to draw two magnets by indicating north and south, two poles of a magnet. Next, rectangular coil, that is armature, should be present in between these poles. So consider this is one rectangular loop or rectangular armature coil which is placed. If you want, you can name it as A, B, C and D. Now we are talking about DC motor, so we have to use split ring. Connect these two ends of armature to two split ring. Here we have one split ring. Here you have another split ring. You can, if you want, you can name it as S1, S2. First split ring, second split ring. And that should be connected to brushes, two carbon brushes. Here we have one brush. Here we have another brush. You can name these brushes as B1 and B2, brush 1 and brush 2, and this should be connected to a cell or battery. Consider we have positive terminal here, negative terminal here, which is connected here, and this brush is connected to negative terminal of the battery. Guys, if you want, you can use key switch, it's your wish. Okay, now this is just a schematic diagram. And for support, if you want, you can draw one axle here. So two split rings will be mounted on it, axle. So while coming to this diagram, now you can find two permanent magnets and rectangular coil. Rectangular coil is connected to two split rings and which is connected to brushes, and at last it is connected to cell or battery, or simply to say power supply. Now consider there is no current in the circuit, no current. If there is no current, what will happen means there will be no RPM, there will be no rotations, motor will not work. Before that, one thing you have to understand about magnetic field. Guys, north pole is here, south pole is here. We know always magnetic field lines will be from north to south, isn't it? Remember that, will be very useful while learning about this motor. Always it will be from north to south directly. So now pass some current through the circuit. If you pass current through the circuit, what will happen? Okay, let us see. There is positive here, negative is here. Consider current is passing in this direction and it is moving up and it is going here, entering through brush 1 and it is entering through split ring 1, B1 S1, and current is going in this direction to the rectangular coil, and first current will pass from A to B, then current will pass from A to B, then B to C, and then C to D, and then D to second split ring S2, second brush B2, and that eventually current will come out to the negative. So this is the direction of current. So we have magnetic field which is represented with B, current which is represented with I. Now what is remaining? Force, that's it, right? Three parameters we have to consider: magnetic field, current, and force. Now you see guys, apply here, apply Fleming's left hand rule. If you apply, now you see this is the direction of, wait a minute, I'll take one new color and I'll come back to you. Let us take this orange. Okay guys, this is the direction of current, this is direction of magnetic field. Are you getting it? So this is direction of current, this is direction of magnetic field. Now what should be the direction of force? Apply left hand rule. So if you see, while coming to left hand rule, your forefinger indicates field, middle finger indicates current, your thumb indicates force or motion. Now try to apply that. So your first current means middle finger should be straight like this, and magnetic field should be like this. I think so you can see me on screen like this, right? Current is moving in this direction and magnetic field is in this direction. How my thumb is directing? Down, isn't it? So automatically force will be downwards. That force will be downwards. So what will happen if electricity is given? Automatically this CD limb will move upwards and this BA limb will turn downwards. So it will take half rotation like this. After half rotation, what will happen? You can find, so consider this diagram. This one is first. After half rotation, this C will be here, this D will be here, B will go this direction, A will be this side, split ring S2 will come here, split ring S1 will come here. So entire rotatory part, rotor, will take one turn like this, not one turn, half turn it will take. Now what will happen? Are we changing any direction of current? There is no change in current direction. So current is going like this only, same direction. Now current is moving through CD. What is magnetic field? Magnetic field is in this direction. Current is in this direction. What about the magnet? This is magnetic field B. This is current I. What about the force? That will be downward direction. Again, it will take half turn. So first half turn, second half turn. Like that, what will happen? There is continuous rotation in the motor until you stop the current. Are you getting it? Now what will happen? This CD limb will come this side and AB limb will go that side, and hence it will become again AB, then it is CD. So like this, if you observe this diagram, you will get some idea. This one. So this is direction of current. This is direction of magnetic field. Now what is the direction of force? This. So it will take one rotation. Again, it will take another rotation. Like that, continuous spinning will be there in the motor. Like that, motor works. Very simple concept. Basically, you see guys, this magnet is producing magnetic field now. This is armature where current is passed. Around this armature also there will be magnetic field, isn't it? There is magnetic field here. Around this armature also there will be magnetic field. What we have discussed in last lecture, when you have two magnets, literally we have two magnetic fields. When you have two magnetic fields, that leads to attraction or repulsion. Whenever you have attraction or repulsion, that leads to motion. Do you remember? Whenever this coil is placed in magnetic field, okay, once again I will draw. You see here we have magnet. Consider this is north, this one is south. And we have armature segment like this. Now you see guys, from here if you are passing electric current I, what will happen? Apply, you see for this armature, apply right hand rule. And if you apply right hand rule, this is direction of current. Now what about the direction of magnetic field? Will be around it, isn't it? Now this is kept in magnetic field. There is magnet and there is magnet, and this magnet field is like this. Now how many magnetic fields we have? Two magnetic fields we have. Because of two magnetic fields, what will happen? Force is produced. If you observe the flow chart which we have discussed in last lecture, this is the flow chart, I guess. Now let us apply this one to the motor. Magnet, yes, already we have magnet of north and south pole. Automatically this magnet, what it will do? It will produce magnetic field, static part. And we took current carrying conductor. We have passed current to the this conductor is nothing but rectangular coil, or simply to say armature. For that armature, what we did? We have passed electricity that has become magnet. Now that will have magnetic field. When two magnetic fields we have either attraction or repulsion, which causes motion where force is produced. That is working of motor. And where you can find commercial uses, where it is used in electric car, rotatory mill, electric canes, lift, etc. So that is working of electric motor. In our next lecture, we will discuss about working of AC motor and difference between AC motor and DC motor, and we will discuss one new topic, that is electromagnetic induction. So that is in our next lecture, we are going to discuss about difference between AC and DC motor, and we are going to learn a new topic, that is electromagnetic induction, EMI, which is used and which is a principle of working generator, or we can call it as dynamo. That's it in this lecture.